Our journey begins in Saqqara, Egypt, a place where the golden sands stretch endlessly beneath a relentless sun, and the air shimmers with the heat of ancient secrets. Here the desert has guarded mysteries for thousands of years, its dunes shifting but never revealing all they conceal. Rising from this timeless landscape stands the Step Pyramid of Djoser, the world's very first skyscraper, constructed nearly 4,700 years ago, long before the famous pyramids of Giza. Unlike the smooth-sided pyramids that would come later at Giza, this stepped monument was the original blueprint, the bold experiment that sparked Egypt's age of monumental stone architecture. But the big question remains, how did ancient builders achieve such a feat with the tools and knowledge of their time? Imagine, hundreds of thousands of tons of limestone, quarried, transported, and stacked, all with what we assume were primitive tools and sheer determination. The standard explanation is simple: ramps, ropes, and raw manpower, with thousands of laborers working in unison. Yet as we examine the evidence more closely, doubts begin to surface. Could it really have been that straightforward? The logistics are staggering, moving multi-ton blocks up over 200 feet, with limited timber, basic copper tools, and no modern machinery. The traditional theories feel incomplete, like a puzzle with crucial pieces missing, leaving us with more questions than answers. Every new artifact unearthed in these sands challenges our assumptions and forces us to rethink what we thought we knew about ancient Egypt. This pyramid isn't just a tomb, it's a silent witness to the ingenuity, ambition, and creativity of a civilization that shaped history. What if the Egyptians relied on more than muscle? What if they harnessed the hidden power of water to move these massive stones? Some researchers now believe that evidence of advanced hydraulic engineering lies right here, concealed beneath the pyramid's foundations. If this theory proves true, it could completely rewrite our understanding of ancient technology and the capabilities of early civilizations. So, gather your curiosity and your gear. We're not searching for gold or treasure. We're searching for answers, for the truth hidden beneath centuries of sand. Join us as we investigate one of history's greatest construction mysteries and perhaps uncover secrets that have been waiting millennia to be revealed. Travel back to 2700 BCE, a time when the sands of Egypt held secrets and the Nile nourished a civilization on the rise. This was the era of King Djoser, a visionary pharaoh whose ambitions would forever change the face of Egypt. Before Djoser, pharaohs were laid to rest in modest, flat-roofed mastabas made from sun-baked mud brick, simple structures that barely hinted at the grandeur to come. But Djoser dreamed bigger. He envisioned a monument that would reach toward the heavens, a stairway for his soul, a symbol of his divine authority and eternal legacy. To realize this dream, he turned to Imhotep, his brilliant vizier, high priest and architect, a man whose name would echo through history. Imhotep's revolutionary idea was to stack 6 mastabas, each smaller than the last, one atop another, forming a stepped pyramid that soared 204 feet into the sky. This was a leap forward, not just in shape, but in material. For the first time, stone replaced mud brick, signaling a new era in Egyptian construction. The task was monumental, quarrying, transporting, and lifting over 330,000 cubic meters of stone, all without the benefit of modern technology. No cranes, no engines, just ropes, sledges, ramps, and the relentless determination of thousands of skilled workers. The Step Pyramid complex was more than a tomb. It was an entire walled city for the dead, filled with temples, courtyards, and ceremonial spaces. Building it required unprecedented planning, organization, and technical skill, an achievement that set new standards for generations to come. This was the prototype for all future pyramids, laying the foundation for Egypt's golden age of stone construction and inspiring countless monuments. Yet the greatest mystery endures. How did they lift and position those massive stones with such precision? Imhotep's genius is undeniable, but the exact mechanics of his methods are still fiercely debated by scholars and engineers today. Solving this puzzle isn't just about understanding history. It's about honoring the ingenuity and creativity of ancient innovators who shaped our world. The Step Pyramid marks the moment when architecture became truly monumental, a beacon of human ambition and imagination. Its secrets still lie buried in the sands, waiting for the next generation of explorers to uncover them. For decades, the leading theory was simple: ramps. Some imagine a massive straight ramp, others a spiral wrapping around the pyramid. But a straight ramp would have been longer than the pyramid itself. and there's little evidence it ever existed. Spiral ramps solve some problems but create others: tight corners, blocked sight lines, and tricky logistics. All ramp theories rely on thousands of workers hauling stones with ropes and sleds. The Egyptians were master organizers, mobilizing labor during the Nile's flood season. But as the pyramid rose, workspace shrank, making it harder to fit enough workers at the top. The sheer speed and precision required seem almost impossible with brute force alone. It's like building a skyscraper with only hammers and nails. The ramp theory explains a lot, but not everything. That's why alternative ideas keep emerging. Enter a radical new idea: the water shaft theory. Researchers like Dr. Peter James and Chris Massey propose that the Egyptians used water power, not just muscle. The key clue: the massive trench or moat surrounding the Step Pyramid complex. Traditionally seen as symbolic, what if this moat was a giant reservoir? The theory suggests water from the moat was channeled into a network of shafts beneath the pyramid. Beneath Djoser's pyramid lies a labyrinth of tunnels and a huge central shaft. What if these weren't just tombs but parts of a hydraulic lifting system? Flood the shaft, seal it, and use water pressure to lift stone blocks. This would make the Egyptians not just builders but hydraulic engineers. It's a complete paradigm shift, seeing the pyramid as a dynamic machine, not just a monument. If true, it changes everything we thought we knew about ancient construction. Let's see how this hydraulic system might have worked. How would a water-powered lift work in ancient Egypt? First, fill the outer moat with water, likely diverted from the Nile. The moat becomes a giant reservoir, storing potential energy. Next, channel water into vertical shafts beneath the pyramid. At the bottom, place a buoyant float, maybe a sealed wooden box or papyrus raft with a stone block on top. As water fills the shaft, the float rises, lifting the stone. It's Archimedes' principle in action: buoyancy doing the heavy lifting. For heavier blocks, a sealed shaft could use water pressure like a giant piston, pushing the stone up. Once at the right height, the block is slid into place. Drain the shaft, lower the float, and repeat. Multiple lifts could create an efficient assembly line, raising stones quickly and precisely. This system would need fewer workers and allow for greater accuracy. Ingenious, if the Egyptians could pull it off. But is there evidence they did? Is there proof for the water shaft theory? The moat is the first clue. Its size makes sense as a reservoir, not just a boundary. Archaeologists have found ancient canals linking Saqqara to the Nile, supporting the idea of water management. Underground, the Step Pyramid's maze of tunnels and the central shaft could be ideal for hydraulic lifts. Some passages are granite-plugged and seem designed to be watertight. Pottery discs found at the site may have been used as valves to control water flow. The Egyptians were already masters of irrigation and canal building. Applying that knowledge to construction isn't a stretch. The evidence isn't conclusive, but it's compelling. The pieces fit together in intriguing ways. Maybe we're looking at the world's oldest hydraulic machine, but not everyone is convinced. The water shaft theory faces serious skepticism. Mainstream Egyptology sticks to ramps, no need for lost technology or advanced physics. Critics point out there's no ancient text or artwork showing a hydraulic lift. Waterproofing the shafts would have been a huge challenge with ancient materials. Building massive floats strong enough to lift multi-ton stones is another hurdle. The practical details are fuzzy, and the evidence is circumstantial. Still, the debate is healthy. It pushes us to re-examine the evidence and think creatively. Supporters argue that absence of proof isn't proof of absence. The physical clues at Saqqara are intriguing, even if the theory isn't proven. The mystery keeps the conversation and the search alive. If the water shaft theory is ever proven, it would revolutionize our view of ancient Egypt, fundamentally changing what we thought we knew about one of the world's oldest civilizations. It would mean that the secrets of the pyramids go far beyond what's written in textbooks, opening up a whole new chapter in our understanding of history. It would show the Egyptians as not just master builders, but scientific innovators who were capable of solving complex engineering problems with creativity and intelligence. Their achievements would be seen in a new light, as products of both skill and scientific curiosity. The Greeks get credit for discovering hydraulics, but maybe Imhotep beat them by centuries. Imagine if the true origins of hydraulic engineering actually began on the banks of the Nile, with an Egyptian genius whose ideas were ahead of his time. This would mean scientific progress isn't always linear. Sometimes knowledge is gained, lost, and rediscovered. History is full of forgotten breakthroughs, and the water shaft theory could be one of the most significant examples. The Egyptians may have had a practical grasp of physics, even if they never wrote it down in the way we expect. Their understanding might have been passed down through generations by word of mouth, or hidden in the details of their monuments. It would elevate Imhotep from architect to inventor of hydraulic power, placing him among the greatest minds in history. His legacy would be redefined, inspiring new generations to look deeper into the past for lost knowledge, and it would force us to rethink other ancient mysteries. What else did our ancestors know that we've forgotten? What other secrets are waiting to be uncovered beneath the sands of time? The water shaft theory challenges us to look for lost ingenuity, not just brute force. It encourages us to see ancient construction as a blend of intelligence, experimentation, and resourcefulness. It's a reminder that ancient people were as clever as we are, facing their own challenges with determination and inventiveness. Their world may have looked different, but their minds were just as sharp. Whether true or not, the theory inspires us to see the Step Pyramid as a monument to human potential, a testament to what can be achieved when people dare to dream big and push the boundaries of what's possible. It's not just a pile of stones, it's a symbol of what's possible when imagination meets determination, and when knowledge is passed from one generation to the next. And it keeps us searching for answers, reminding us that history is never truly finished. There's always more to discover if we're willing to look. As our expedition ends, the Step Pyramid still guards its secrets. The water shaft theory is bold but unproven. The debate between ramps and water power will continue, driving new research and discoveries. Saqqara is still an active dig site, revealing new finds every year: coffins, burial shafts, temples. Each discovery adds to the puzzle. The real lesson: the ancient world is full of secrets, and history is never finished. We must keep questioning, keep digging, and never settle for easy answers. The water shaft theory is a brilliant question, forcing us to see the evidence in new ways. The people who built these monuments were not primitive. They were resourceful, inventive, and bold. The Step Pyramid stands as a testament to their ambition and genius. Whether built with ramps, water, or something else, its true power is in the mystery it preserves. It challenges us to keep searching for the truth. The sands of Saqqara have more stories to tell, and our expedition is far from over.